Hey, we're going to revisit a topic that I think you were introduced to back in Algebra 1 at some point. But man, it's been a while since you've seen it. So we're going to revisit some piecewise functions. We're not going to worry about graphing them so much tonight, but we're going to practice evaluating them and looking at, okay, based on the restricted domains, which function is the quote unquote active function. So let's take a look. What are we going to see in this video? Basically, we're going to focus on one type of example. Here's an example of a piecewise function right here. You've got these are your domains that we'll talk about here in a little while. And we're just going to, based on those domains, we're going to try to evaluate something like f of 0, f of 2, f of 5. And basically, each time we go to evaluate one of those, we've got to decide, do I want 2x plus 10 to be my active function, or do I want x squared plus x to be my active function? So that's where we're heading tonight. So real quickly, what is a piecewise function? It's going to be a function that's defined by two or more equations over specified domains, and that's what we call a piecewise function. What's really exciting for me, the reason I like them so much, we use piecewise function to describe situations where a rule or a relationship changes as the input value crosses certain boundaries, And so what does that all mean? Let's take a look at an example. This was an experience that I had not too long ago that I think you probably could identify with. I bet you've had a really similar one. So I was hosting a clinic and I wanted to give each attendee a custom notebook to give it a nice personal touch. And so I designed these notebooks on Vistaprint. When I went to order them, of course, they've got these different price ranges to try to encourage you to buy more. And so here were some of the breakdowns. If I bought 15 or less, they each cost $18.99 per notebook, and the shipping was going to be a grand total of $8.99. Now, if I ordered between 16 and 50 of them, the price dropped a little bit and the shipping dropped a little bit. And then, of course, if I went real big and ordered more than 50, the price was going to be $14.99 per notebook, and then the shipping was going to be free. So I kind of took all that and I created what I called my cost function. And you can see that's why I'm using the letter C here, where X represents the number of notebooks I'm going to order. So I knew, okay, if I'm going to order 12 notebooks, let's see, 12 falls within this domain right here. So what I would do is I'd substitute a 12 for X, and this equation here would tell me my cost of ordering 12. Or maybe I needed 30 notebooks. Maybe I had 30 people pre-register. 30 falls in this domain. So all I would do is I would substitute the 30 for this X, and this is the only function that I would pay attention to. Or if we had a really good pre-registration, then maybe we need to order more than 50. And so maybe we had 60 people pre-register. 60 is greater than 50, so I'd substitute the 60 in for this X. So basically the nutshell is you're only going to use one of those functions. It looks big and scary. You see three, but based on the domain, you're going to pick one of them. So let's see here. Here's my first example that we'll try to tackle together. If you can read my handwriting here. So basically, look at these domains. For any x that's less than or equal to 0, we're going to use the function x squared minus 2. But if x is bigger than 0, let's see, if x is greater than 0, then I've got to use this function here. So right out of the gates, we want to evaluate f of negative 2. This negative 2 is less than 0, so we're going to use this function right here. So I'm going to say negative 2 squared minus 2. 4 minus 2 makes 2. Now, where does the 0 fit? 0. Now, here you got to look at your equal sign. See, here's the equal sign right here. So you're going to stay with this domain right here, substitute it into here. 0 squared minus 2 makes negative 2. Now, what about x equals 1? That's the first one that is greater than 0. So here's my domain. Here's my corresponding function. 1 minus 1 makes 0. How about negative 4? Where does the negative 4 fall? He is less than or equal to 0. So you're going back to this function right here. Good parentheses. Now remember, squaring it makes positive 16. 16 minus 2 makes 14. All right, let's take a look at maybe an even more intimidating piecewise function. So now with this piecewise function consists of, there's 3 different domains. So now we're working with 3 different functions. So if we wanted, let's say, okay, I got x equals negative 5. Who is the active function? Well, we could say that negative 5 is less than or equal to negative 1. So then, therefore, negative 2x plus 4 is the active function. Substituting a negative 5 makes 14. All right, what about, let's see, what about 0? Let's see where 0 takes us. 0 is somewhere between negative 1 and 2. So now here's my active function. Ironically, what's weird about this one is there's no x to substitute the 0 into, so the answer is just strictly 5. Okay, moving on here. Let's see. I got x equals 2. And because of I'm looking at the equal sign, so I think it satisfies this domain right here. I'm going to substitute the 2 right there. So sine of pi over x is my active function. So pi over 2. And we may have to check our notebook. It's probably been a little while since we did our trig values, but that's going to be 1. Okay, let's keep going. Where does negative 1 fall? Negative 1, because of the equal sign, falls in this domain. So you want this function right here. Negative 2 times negative 1 plus 4 is going to make 6. Yeah, I got just a little room there. All right, now this is a positive 1, which is going to fall in this domain. So the answer is just 5. 3 falls in this domain. So we're going to evaluate the sine of pi over 3, which in the sine of 60 degrees is radical 3 divided by 2. So there's my answer. How about negative 10? That falls up here in this. So we're going to use negative 2x plus 4. Watch that, negative times a negative, so your answer is going to be 24. And then last but not least, the 6 falls in this domain right here. So we're going to evaluate the sine of pi over 6. Sine of 30 degrees is 1/2. So hopefully don't worry too much about those trig values. I don't think we're going to see too many of them, at least right now. We'll get into more of those down the road. But I can't stress this enough. For each problem that I evaluated, once I identified what domain it fit in, I'm only evaluating one of these 3 functions right here. All right. This last one I want to get into, they've given us the graph, and I want to pretend, if you'll play along with me, let's pretend like they didn't even give us these equations. So I'm going to kind of ignore these for the time being. And let's see. We're just going to make up a few here to practice in. What is f of negative 5? Just from reading the graph. Well, what you're going to do is you're going to walk negative 5 on the x, hit that graph, and it looks like the answer is going to be negative 2. All right, what's f of 2? This is an interesting one, f of 2. So now you're going to go to 2, you go up until you hit the graph. Now in this situation, you're going to focus on the closed circle, ignore that open circle that's just above it. So in this case here, it's kind of like the moment where the piecewise function jumps or skips. You're going to look at the closed circle only. So the answer is 4, not 6. All right. Let's see. What's f of negative 1? Looks like that's going to be a positive 1. What's f of 5? What would you say there? That's going to put us at 6. All right, so I hope we've built some confidence here with evaluating piecewise functions. Keep chugging, and don't be afraid. If you've got any questions, throw it in the comments below or shoot me an email, and we'll get back to you as soon as we can. All right, folks, have a great night.